So here I'd like to solve the radical equation. Square root of x plus 5 minus square root of x minus 3 with a radical equals 2. So our strategy here is going to be to get one of the radicals by themselves. So I'm going to get, I'll get this one here by itself that I underlined in red. That's the easiest one to get by itself. So we're going to add square root of x minus 3 to both sides. And when I do that, I'm going to have the square root of x plus 5 equals, on the right side, I'm going to have, 2 plus square root of x minus 3. So now that we have the square root of x plus 5 by itself, we're going to square both sides. We want to square both sides so we get rid of the radical on the left side. So we're going to square the left side. And whatever we do to the left side, we want to do to the right side as well. We're going to take 2 plus the square root of x minus 3, and we're going to square that. So on the left side, the square, the pink square, the purple square is going to cancel the square root, and we're going to have simply x plus 5. And on the right side, when we're squaring that expression, that means you have to multiply it by itself. So we're going to have 2 plus radical x minus 3 multiplied by 2 plus radical x minus 3. So on the left side, I'm just going to have x plus 5. I'm going to copy that down. On the right side, I'm going to have to FOIL. First terms, 2 times 2 is 4. The outer terms, 2 times radical x minus 3 is going to give me positive 2 radical x minus 3. Inner terms, radical x minus 3 times 2 is going to be positive 2 radical x minus 3. And the last terms, when I take radical x minus 3 times radical x minus 3, I'll just multiply them like that together. Radical x minus 3 times radical x minus 3. We want to clean this up. So the left side, x plus 5. On the right side, we have 4. And notice there's like terms here. 2 radical x minus 3 and 2 radical x minus 3 is going to give me positive 4 radical x minus 3. And then here on the far right, anytime I multiply a radical by itself, that's the same as squaring, right? Squaring that radical. So the squaring is going to kill off the square root, so we'll just have x minus 3. Yeah, think about that. If I take radical x minus 3 times radical x minus 3, that's the same thing as saying radical x minus 3 squared, right? And the square cancels with the square root, so I get x minus 3. So that's what I'm doing over there. Right there. Okay, erase that. Okay, so I've simplified this to a point. Notice that the equation that we currently have still has one radical. And anytime we have a radical in an equation, we want to get the radical expression by itself. So what I'm going to do, I'm going to get rid of this 4. Get rid of this 4. So how am I going to get rid of 4? I'm going to subtract 4 from both sides. Get this to right, maybe that'd be good. I want to get rid of this x, so I'm going to subtract x from both sides. And I want to get rid of this minus 3, so I'm going to add 3 to both sides. So on the left side, it looks like I'm going to have x cancels with minus x, and it looks like we have 5 minus 4 and minus 3. What's that? 5 minus 4 and minus 3. 5 minus 4 is 1, plus 3 is 4, so I'm going to have 4 equals, on the right side, we're going to have the 4 cancel with the minus 4, the x cancel with the minus x, and the minus 3 cancel with the plus 3. And all we have left on the right side is 4 square root of x minus 3. So solving this radical equation, now that we have the radical part by itself, we're going to square both sides. Square both sides. On the left, it's going to give me 16. On the right, I'm going to do 4 squared. 4 squared is 16. And when I square the square root dies off, I get x minus 3. So to solve that, we can divide both sides by a 16. There the 16s cancel, we get 1. Equals, here the 16s cancel, we get x minus 3. You just want to add 3 to both sides. That's going to give us 4 is equal to x, potentially. Now remember, anytime you're doing a radical equation, you want to check your work to make sure that potential solution is truly a solution. So we're going to plug back in. We're going to check. We're going to check 4 for x. So I'm going to plug back into that equation. Here's the equation. It's blank plus 5. Radical over top of that minus blank minus 3. Radical over top of that equals 2. Let's plug in 4. 4 here. 4 here. That'll give me, let's see, square root of 9 minus 4 minus 3 is 1. Is that equal to 2? Well, square root of 9 is 3. Square root of 1 is 1. 3 minus 1 is 2. Yes, checks. So 4 is a good solution. So that's our answer to that. 4 is the solution to the original equation. All right. Now let's just do another for practice. So we got the square root of 6x plus 1 minus the square root of x minus 4 equals 5. So I'm going to get one of the radicals by itself. I think it's easiest to get the 6x plus 1 radical by itself. So here I'm going to add square root of x minus 4 to both sides. That'll give me, on the left side, the square root of 6x plus 1 equals 5 plus the square root of x minus 4. Okay, so now to get rid of this radical, we're going to square both sides. I'm going to take 6x plus 1's radical and square that. I'm going to take the right side, which is 5 plus root of x minus 4. I'm going to square that. On the left side, the red square cancels with the blue square root. I'll just have the blue 6x plus 1. On the right side, we have to FOIL, right? 5 plus root x minus 4. 5 plus root x minus 4. So we have 6x plus 1 on the left. And on the right, we FOIL. 5 times 5 is 25. 5 times the root is 5 root x minus 4. The root times 5 is 5 times the root x minus 4. And the root times itself is just going to give us positive x minus 4. Okay, first, outer, inner, last. We did FOIL. So I'm going to collect my like terms on my right side. I'm going to leave the left side as it is, 6x minus 1 if it'll write. Thanks. 6x plus 1, 6 plus x plus 1. On the right side, we're going to collect our like terms. Notice we have 25 and minus 4. That's going to be 21. And we're going to collect the other like terms. Here, the 5 root. 5 root there. That's going to give us 10 root, right? 10 radical x minus 4. So 10, yeah, it's not working. Root x minus 4. That's when you combine those two roots together. And don't forget we have an x there as well, right? We have an x right here. Yeah, if I could get it to stay. There it goes. Nope, still not working. There it goes. Okay, so you want to get the radical, that kind of purplish, pinkish term, you want to get by itself. So we can subtract 21 from both sides. And we can subtract x from both sides. So on the left side, I'm going to do 6x minus x. 6x minus x is going to be 5x. And 1 minus 21. 1 minus 21 is minus 20. We got the equal sign. And then on the right, we're just going to have the 10 radical term. 10 radical x minus 4. So we're going to have to eliminate that radical. So let's square each side. I'm going to square this side. And if I do the right side, I have to do the left side. So on the left side, I'm going to multiply out, FOIL out 5x minus 20 times 5x minus 20. That's what it means to square. On the right side, I'm going to have 10 squared is 100. And the radical squared is going to give me x minus 4. So on the left, I'm going to FOIL. I'm going to do 5x times 5x is 25x squared. 5x times minus 20 is minus 100x. Negative 20 times 5x is negative 100x. And negative 20 times negative 20 is positive 400. So that's foiling on the left. On the right, we're going to actually distribute a little. We're going to take 100. I get this to work. There it goes. 100 times x is 100x. 100 times minus 4 is minus 400. So this is obviously a quadratic equation. We're going to collect the like terms together here on the left side. Notice you got these minus 100s, right? Minus 100, minus 100. So we're going to have 25x squared minus 200x plus 400 equals 100x minus 400. So as a quadratic equation, we want 0 on one side. We'll subtract 100x from each side. And we'll add 400 to both sides. That means on the left side, I'll have 25x squared. Negative 200 and negative 100x are going to be negative 300x. 400 plus 400 is going to be 800. And on the right side, we're going to get some cancellations, right? We get 0. Now, this is a quadratic equation, and we can solve this by factoring, or we could solve this by using quadratic formula. But first, I'm going to notice that, hey, look at this. These all have a 25 in common, right? You can divide all these by 25. I'm going to divide the whole left side by 25, and the whole right side by 25. So 25 divided by 25 is 1. So we're just going to have here, that cancels. We got x squared. 300 divided by 25 is, I believe, 12. So we have 12x. And 800 divided by 25, that is going to be, let's see, 800 divided by 32. And on the right side, 0 divided by 25 is 0. 0 divided by anything else is 0. So this can be factored. This can be completely factored. So I'm going to make 2 pairs of parentheses. All this is equal to 0. I'm going to start with x times an x to get x squared. And then I'm going to find 2 numbers that multiply to give 32, right? And add to give. So multiply to give 32 and add to give minus 12. you'll come up with two numbers like -4 and -8, right? -4 times -8. Multiply to give 32 and add to give -12. So I'm going to have -4 minus 8. And then by the zero product property, if something times something is 0, then one of those has to be 0. So I'm going to set either x minus 4 equal to 0 or x minus 8 equal to 0. And in that case, we can add 4 to both sides on the first equation and 8 to both sides on the second equation, whereby we get x equals 4 as a potential solution or x equals 8 as a potential solution. So I'm going to put dotted lines around these. These are potential solutions. We need to check them. If I can plug in 4 into the original equation, see if it checks out. I'm going to plug in 8 to the original equation, see if it checks out. So here's my original equation. Okay, so let's check. Check 4. So we're going to have, let's see, square root of blank. No, back it up some. Square root of 6 times blank plus 1 minus square root of blank minus 4 equals 5. So you plug in 4 for x, the blanks, and you get the square root of 24 plus 1 minus the square root of 4 minus 4 is 0. Is that equal to 5? Well, that means you have the square root of 25 minus square root of 0 is 0 equals 5. In other words, square root of 25 is 5. So you get 5 minus 0 is 5. That checks. So the first one works. 4 works. And then we want to check 8, see if 8 works. Let's plug 8 into the original equation. Square root of 6 times blank plus 1 minus blank minus 4 equals 5. Let's plug in 8 for x. Okay, doing the computations, we're going to get what? 6 times 8 is 48, plus 1 under the radical. Minus in the second radical, 8 minus 4 is 4. Is that equal to 5? Let's see, 48 plus 1 is 49, so we got square root of 49 minus square root of 4 is 2. Is that equal to 5? Square root of 49 is 7. 7 minus 2, is that equal to 5? Yeah, it's equal to 5. So that is a good solution as well. Okay, so there we have it. Radical